I'm going to talk about Diffing XML. And I'm Martijn Faassen. I've been programming in a variety of languages. Years ago, 20 years ago almost, I created the LXML library for Python and dealt with some of the issues just discussed in the last talk, so that was quite interesting because I was binding to libxml2. And more recently, I built a tool with Peligo, who hired me to do this, a diffing tool for documents, XML documents. And Peligo is a company in Sweden, and they make a CMS also called Peligo for technical documentation and sort of other knowledge management style data. And it's docbook based, so you can kind of imagine why diffing XML documents might be useful. Yeah, diffing XML, you have two documents, a source document A, a target document B, and you want to be able to express the differences between them. And yeah, it's the last day of the conference, right? And it's 5 o'clock. Yesterday at 4 o'clock, I was already very tired. And I'm going to talk about how this algorithm works to you all now, so, you know, enjoy. Yeah, here we have a very dumb source document, and we have a target document, and you can see that the C element has been inserted, and there's a little annotation here now created by the diffing tool to show the difference. So what were the goals of this project? Well, obviously we wanted to create differences between documents that were correct, right? Like not the wrong differences. And specifically, we want to be able, like given the diff document that I just showed, we want to be able to reconstruct both the source and the target document successfully. That's sort of a test of validity. And that's a necessary goal, but it's not a sufficient goal for a diffing library, because I could just write this diffing library that always did this, just throw away the source document, and then insert the target document. It's always valid. This is fine, right? It's correct. I'm done. Please pay me now. But yeah, that's not good enough. We want human-readable diffs. You want diffs that are a bit like what a human would actually, how they would express it. And they wouldn't say, oh, well, I threw away the old document and I wrote a whole new document and it's entirely different. They would say, I added this C element, right? And there's also a few non-goals, like we're not aiming for like the technically most compact diffs, even though compact diff there might be overlap with human readability there, and it's not about the most efficient sort of diffing approach either, and it's really specifically about documents rather than data. So think about diffing docbook, for instance. The algorithm that I didn't come up with myself, but I'm getting ahead of myself, it uses the text content of the document to help try to make better differences. And algorithm could be used to diff any XML, but the quality will probably suffer because there's less sort of textual document style overlaps to sort of anchor the diff. And it was also important that this is production quality. It shouldn't just be, you know, a prototype. It should be reliable and maintainable and fast enough also for moderate-sized documents. Large documents, really big ones, I haven't tested it on. For moderate-sized documents, some of the systems that I looked at that already exist struggled even with moderate-sized documents. And since I'm here at the XML conference, and I'm kind of new here, first time at an XML conference, I have sort of this question about where this name XML came from, because, you know, Bill Gates, as everybody knows, invented the internet, right? Bill Gates invented the internet, not Al Gore, that's a lie, it was Bill Gates. So since I'm new here and there's this XML thing and it starts with X, I was kind of like, Elon Musk is really into the letter X, so I figured that, did he implement, or did he invent XML? Is that the true story, or am I missing something? Anyway, let's look at diffs. You know, what kind of diffs? There's a bit of notation. Red, without any special marking, is delete. Green, with underline, is an insert, and blue is just an updated piece. And I've used indentation in these examples, even though that would really screw up diffs if you start indenting things, but it really helps with clarity, so I've indented stuff here. So inserting, we already seen. All right, what did I do? Is it picking up again? Well, now we're going to delete, and that's very similar. So we just mark the element with that it's been deleted. And you can also like modify text. So here we're adding the word or the string world with the exclamation mark, and that's marked up with a text insert element just to show that that has happened. Similarly, deletion is the inverse. You can also do stuff like attributes, right? If you know that an element, well, if you suspect an element is an update of another element, then you can express, somehow, the details of this don't really matter, but there's an element inserted as the first child that sort of describes the changes to the attributes that have happened. And it also should support the other XML stuff, processing instructions and comments. And then there's like a few kind of more slightly higher level operations. Here we are not, world was already in the original text, we're only adding an element around it. That's like a wrap operation. And it's different from the insert where the whole thing is inserted. And you can also, well, that's expressed like this. So there's a wrap attribute on the B element. And you can also do that for unwrap. And other diffs are possible, but I haven't looked into them. Like move operations, there's all kinds of sort of fancier, higher level diffs. The more fancy you get, the harder it might be to easily represent what the diff is, but that's sort of the collection I showed just now is more or less what Natural-xml-diff supports. So, I started this project and it's like, okay, how do you diff XML? How do you come up with a way to do that? And I had a starting point, an XML library or an XML-diff library, Python library, implemented by a friend of mine who referred this project to me. That's based on a paper from before XML, so really old now, I guess. But the problem with this library, my Pligo had tested it, it didn't really produce human-readable diffs on various sort of small examples. And it struggled also, like performance-wise, with even medium-sized documents. So I looked at it, thought, can I improve this algorithm? And I thought, well, let's step back, let's look at the literature, see what people have done with XML diffs. How do you do an XML diff in the first place, like a tree structural diff? And then I had a stroke of luck because I found a 2020 paper that did a whole literature research of the last 20 years or so of XML diffing tools, and it focused on document-style diffs, which is exactly what I needed. And it compared and tried to estimate their quality, like how good is this to a human being? Does it look human readable? And so I was very happy. Thank you, authors, for doing all that work for me. And I also learned, we want human readable diffs. This is not just about a generic tree diffing algorithm, it's really about human readable diffs. And the paper that, the overview paper had a candidate that stood out called JNDiff, and I tried it out and it worked well on our test cases. And there were a bunch of papers explaining how it worked. But there were a few problems. There was a code base in Java, and it was last updated 10 years ago, and it had comments by the academic developers of the software in Italian, and it was hosted on SourceForge, so it's kind of like, yeah, that's kind of what the state of that is. If it's on SourceForge, that it's just resting, I guess. But the paper described the algorithm, and the source code was there. So I took a good look at that paper and decided that the best way to sort of create a maintainable version of this stuff is to try to re-implement this algorithm, was described, it looked doable, and to really focus on making production quality and fine-tuning it where possible. And I chose, because I have a hammer, in my case that's Rust, I chose Rust as the implementation language. I like Rust a lot. Ask me about Rust. It's like a systems programming language that avoids some of the problems with memory management that C and C++ have. and yeah, fits this domain fairly well because you need the performance. So how does JN-diff work? Well, the key insight, and I already sort of referred to it a little bit earlier, is that you have these sequences of identical content, like the text of the document, including the markup. It sort of anchors the rest of the difference of the diff. And what it does first is it sort of flattens these documents into arrays because it needs to do a lot of comparison. The algorithm really needs to do a lot of comparison operations, and you can do that faster if you just flatten them first into arrays of nodes. Like in document order, you just flatten it all out and you have the same information. And then it does something called partitioning. And what it does is it looks in document A and B, like on the top, and it looks for like things that are exactly the same, like a sequence of nodes, not an XDM sequence, an array of nodes that are identical between the two documents. It tries to look for that and looks for the longest one. So it does a lot of comparison to try to find sort of this, and then it finds the blue bar, and it has found this overlap, and then, well, it has two halves left, so then it starts looking in those halves for the longest bit that's available there. And then it keeps doing that recursively until it cannot find any identical nodes anymore. And then you have the left. And I stole this, I didn't want to draw the tree myself, so I stole this graphic from the paper about JN-diff. But you see here, like on the top is like document A, and then you have document B here, and you see here as identify like whole sections of the document in green in this case that are just exactly the same. And it doesn't have to be like a rooted bit, it can be a fragment like that. Then, you have the gaps left where there are no exact overlaps, but you still suspect that somebody has edited the text and there will likely be overlaps. So we assume those things in the beginning. We start out, okay, those things are different, but then we look for similar text nodes on the A and the B sides in those remaining gaps. And we use the Levenstein algorithm, and then we find like text nodes that are very similar to each other. They have to be like 50% similar, otherwise we don't count them as similar at all. We find the most similar ones, which are like, change one letter or something like that. And we remember those are updates, and then we partition again, like what we have left. So we try to look for more updates. And then, yeah, again, I stole this. See here that there's like text 5, which is the string content of the node, that's the text node, and then text 25, so a 2 got inserted, and this algorithm then identifies what the update was. And then there is a process called propagation, which means that the information that's like you have ancestor nodes still, that have maybe a lot of updated nodes sitting under them or identical nodes under them, but we cannot identify them as identical as equal yet or updates yet. But now that we have a lot of nodes sitting underneath that we know we assume are updates or are equal to each other, we can propagate that information. So again, we take like the longest, weightiest, well, in this case, the pieces with the most text, and we propagate that information upwards. So we can identify like these. There's a lot of different potential algorithms or heuristics you can do it. So this heuristic, there's no perfect algorithm for doing human-readable diffs. So you can tweak that quite a bit, which I actually did. And then once you have sort of marked everything, so you've marked like an element as equal, well, then there's no edit, it's just the same. But if you have on the A side, you have a different element, you haven't been able to associate it with anything in B, then you assume it's being deleted. And if you have something different on the B side, you find an element and it's different, you haven't found an update or an equality there, you assume it's an insertion of that element. For text nodes, if there are updates, we can do like a text diff, and then determine what piece of text was inserted. And attribute changes, if we have done our propagation work right, we can find like what has happened to these attributes here. So yeah, when I got the recommendations about how to write a presentation, then I said, well, I should have not more than 20 slides. And we're at slide number 55 now, so I'm doing it wrong. But whatever, let's continue. So I implemented J&Diff algorithm, and then I started testing it with data and taking a look at sort of how well it worked. And then I found a bug. It's always sort of a good sign that you've implemented an algorithm or a paper or a specification correctly if you find a bug in your code, and then the bug actually also exists in the original, which was true in this case. I tried it with J&Diff, and it had the same bug. So J&Diff thinks that these two XML documents are the same because all the nodes occur in the same order. So if you linearize them, they look the same if you don't look at like parent relationships or things like that. So yeah, that's the problem because they're not the same. I fix it by detecting like propagation inconsistency, that if you have something that's considered to be the child of a node in one document, but it's in the other document it's not, there is an inconsistency that I could, and appears to work reliably and resets that so that they are different. So that fixed that issue. Then something that is mentioned in the J&Diff paper, but I actually finding an implementation of it in their Java code base, and the paper was very sparse about how this was supposed to work, is like detecting wraps and detecting unwraps. So I have multiple algorithms. One is related to that, and another one that I'm going to discuss later. Find these things. And again, it's heuristic. You don't always find all of them, but yeah, it does a decent job now. The other thing that I did that the J&Diff tool does support, and the XML-diff Python library also supports, is to produce some kind of diff document that describes the difference. But I really focused on this diff document because I found it much easier to reason about than a sequence of inserts and deletes, delete operations for the many situations. So yeah, here you have your diff document, and I had inside you could refine this diff document. You could refine a list of edits and post-process them, and you could merge or transform these edits, but it's easier to reason about in a diff document. So here's an example, and I found these quite a lot. These were sort of left after the J&Diff document process was done. I would find a combination where a paragraph is deleted, and then another paragraph is inserted. And the deleted and inserted is the content is really different, right? So they hasn't identified it as an update because the content, the text is different enough. But I found that if I merge them, and I say, well, no, I have a paragraph node, and then you have a text insert and a text delete in there, that would actually really improve sort of the quality and readability of the diff. And then another observation was that if you have like multiple deletes and multiple inserts, it turns out that you can reorder deletes and the inserts sort of next to each other, but not their own order. Their own order has to stay the same. Optimize this by reordering stuff, by moving stuff around, and then we suddenly can do merge again, and then we end up with this. So that also really helped improve the quality of the result. And then we left with mixed content. The special thing that XML can do, basically, right? Especially document style, XML has a lot of mixed content. And you would sometimes have a situation where a text node was identified as an update of another text node, but then there was like a bold or something like that, a bold element, and then there was another text node, and really that should be part of the same diff. We figured out a way to optimize these diffs using plain text diffing. Because plain text diffing is already optimized for human readability. Like, these algorithms have been designed to be readable. And I was inspired by XML-diff because I found a little algorithm that did something like that in there. So here's an example. This is a difficult to understand diff. Some text gets deleted, an I element gets deleted, and then there's another text insert. But what basically happens, if you reconstruct the source and the target, which you can do from the diff document, you have the pink big elephant and the pink elephant. That's basically all that happens. So really, you would like to see the I element deleted, but because of various issues with text updates and processing things, this wouldn't always happen. So the idea is to replace the mixed elements with placeholders, and take these placeholders from like a Unicode reserved code page where you can freely use them. They won't never overlap with real Unicode characters, and replace that stuff and remember what replacements you've done, and then do a plain text diff. And then you get like some nice information, and then you reconstruct the XML again from that. And that also really helped improve the diffing result. Then you get like, delete big, which is the thing you would like to see as a human being. And it turned out that this post-processing would have a cumulative effect where this combining of delete and insert pairs combined with this further cleanup stuff would sometimes like really, especially in translated content where the structure is the same, but the different, it would really make that a lot more readable and really express it as text differences instead of element differences. And then, I'm getting sort of near the end. Robust software, you need to test it. So I started out by writing automatic test cases for various diff scenarios that we knew were interesting or problematic. A general system to verify that when we have a diff document, we can always construct a semantically equivalent A and B document, again, from that diff document. We implemented property testing, like randomly generate like documents A and B, some kind of tree, and then check whether that still verifies that that property holds, being able to reconstruct. We had a lot of test data, and we did bulk verify testing against that to check whether it's working. Wrote a HTML visualization tool so we could actually eyeball the diff, because that turned out to be really useful with that merge scenario and stuff. You could really see cases where, hey, this is weird, we can do that better. And I also implemented a simple like metric that I could at least optimize for the size of the diff in the amount of text change. Like if you have like the same two documents and you tweak your diffing algorithms and the size of the changes that are described are smaller, that's a hint that you might have something going on. Then I thought, okay, I need to add another joke here, because after all, we're after 5, we're all tired, day 3. And yeah, it's probably 6 now or something like that. So I'm tired, and so I went, I hear all these talks about AI, so GPT, and I said, well, hey, what's a joke about automated software testing? And then I'm tired, I can't think of any, please help me, ChatGPT. And then it's like, sure, here's a joke about automated software testing. And it's like, why do automated tests never laugh at jokes? Because they always take things literally. And I was like, okay, I don't get it. Is that funny? And then ChatGPT, to compound on its error, the thing you should not really do is to start explaining the joke in great detail about why it was supposed to be funny. So anyway, yeah, there are some challenges left. It's in production now. yeah, Rust is really amazing and how much compile time checking you can do. So it's really solid in the sense there's no crashes or anything like that. The performance is adequate. Also, the diffs produced, are valid, but a use case sort of turned up that I wasn't aware of, and we weren't really aware of sort of initially, is that sometimes with the diff visualization, you don't want to visualize the diff as an XML, but you want to visualize it in the original we're using the original rendering system, like you would render DocBook or something like that. And then you can run into issues with the or the rules of the document, like certain modifications produce a diff document that is a valid XML document, it's a valid diff, but it's not a valid DocBook document. So that's a whole giant can of worms, and I'm currently trying to imagine ways to manage that can of worms, because the whole algorithm right now is not aware, schema aware. There's a few things you can exclude certain attributes from comparison, and I've also fine-tuned it on the data I have, but it's not really aware of a particular XML schema, and now that might be an issue. Purely with the visualization, it's not like the diffs are wrong. So yeah, in conclusion, Natural-xml-diff sort of has practical improvements over many of the publicly available XML-diff implementations. It's a high quality, it produces high quality diffs thanks to the J&diff algorithm and some of the improvements. It appears robust over a wide selection of documents, and we intend to open source it. Any questions?
Thank you very much for the talk. Especially as you mentioned to kind of find wraps and unwraps, because that is the only use case for updated content that is not otherwise changed. I was looking forward to the rest of the talk, but then when you talked about the necessary post-processings, I got the feeling that using the text-based approach, you lost something that is present in solutions that use a tree-aware, XML-aware approach by basically comparing element nodes and looking for identity at that level and knowing about the structure, and you kind of rework some things that they have for granted. And so solutions that take the XML-aware approach, like finding similar elements based on longest common string, selection, Levenstein, whatever, and they kind of have the problem to detect the wrap and the unwrap. Because then if you unwrap something, the element is deleted and the text is inserted. But that is again something that in post-processing could be fixed into, oh, this text is the same and we mark it as updated. So I personally don't see a hard preference for this way to go, because you need some post-processing, you have to do some handling afterwards. So from my point of view, it would most probably come down to raw performance, like comparing the available tools in terms of performance and with large documents, because that's our use case. We have basically, let's say, our customers doing 800 pages documents and creating diffs from them. And on the publication pipeline, we of course handle all these special elements with the namespace.
What is the question?
The question is, I think I would like to see an update of that talk. I would like to see a challenge kind of talk, and you did not convince me until you said you would like to open source it, and I would say we're looking forward to that.
Yeah, I mean, I think you do have a misapprehension. It is a structurally aware diff. The post-processing is just part of the whole algorithm, so it's not some kind of weird thing that just happens afterwards. I'm just describing how the algorithm works. And the algorithm that is doing the longest common subsequence, sort of that whole analysis of creating identical nodes and update nodes, information is not lost. The processing that happens is after we have identified elements with mixed content, and specifically mixed content, that are very similar to each other, then we can do some more work to produce better diffs, which is, I think, you would want for documents. So that text processing, and that diff is also structure aware. It doesn't throw away any information about the identity of nodes there either.
One more question.
Hello, I would like to know how do you decide if a difference is an update or if it's a simple deletion or insertion?
The decision is made by if you cannot find an update, like if you cannot find something that looks sufficiently similar to each other within those gaps, so it could have moved also, and then it will become an insert and deletion. But if it's in the more or less the same place in the structure of the document, that and you cannot find an update, then it must be a delete or an insertion. That's basically how that works.
Yes. Next question.
Thank you very much. I thought that was really interesting, and I think some of the insights that you added later on were really clever and really nice. And I think you said this is your first XML conference, so welcome to the family. I want to ask a really weird and annoying question, so I'm going to begin by saying I've worked on DocBook for a long time, and if you want to chat about how to make the diff documents that will be valid DocBook, hit me up and we can talk about some of those things.
Thank you.
My weird, annoying question is, can you talk a little bit about your choice of attributes for marking diffed things? It looked like they were names with empty string values. It just struck me as a little...
The name, basically the name of the attribute is the same namespace name as the original. So the name of the element is the same name as the name of the attribute. That's why, so that I could reuse the element name for that information.
Okay. Last question.
Thanks for a very interesting and entertaining talk. I'm just wondering what you do about insignificant changes. You mentioned briefly white space, which makes me think that you're treating all white space as significant, but also how about things like attribute ordering, which between two different documents is defined as being unimportant?
Yeah. Attribute ordering is considered unimportant. That's not a diff, right? That's not part of the semantic model of the XML document. White space, I have like, you can turn that on and off, but you can remove, well, what might be insignificant white space, right? Before you do the diff, you can normalize sort of the inputs. There's a bit of code that does that as well.
Thank you very much.
Thank you. I need to get rid of my...